Plucked from the trash, everyday objects are destroyed, then transformed by technology, reborn into modern marvels. Illegal guns are busted into cool cufflinks. Ski boots played again as flutes. Wheelchairs roll into beer kegs. These are the things that are made by destruction. Chicago has a gun problem. Police seize an illegal firearm every 75 minutes. Most of them get destroyed. And now, illegal guns are being used as an accessory to crime stopping. Liberty United turns illegal weapons into bling with a message, aiming to educate at-risk kids and targeting the profits to fund programs that protect them from street-level violence. Illegal guns are reformed into cufflinks. Every month, the Cook County Sheriff's Office pulls hundreds of illegal guns off Chicago's mean streets. Once the guns are released from custody, they're stripped down. The first step in the destruction process is chopping. A metal worker uses a hydraulic cutter to shear the illegal firearms into harmless chunks of steel. He packs up the parts for shipment to the foundry, where they'll be melted and molded into steel bars. The second step in the destruction process is melting. A metal worker feeds the chopped up weapons into an induction furnace. Instead of using an external heat source, an induction furnace heats the metal from the inside out. The furnace is surrounded by a coil of copper wire. The coil creates a rapidly reversing magnetic field that penetrates the metal. The high-frequency electromagnetic field excites the atoms in the steel, generating temperatures of 1,370 degrees Celsius. A foundry worker tips the molten metal into a pouring bucket. He cranes the bucket over to a row of casts and pours the liquid steel into ingot trays. After an hour, the ingots harden enough to be released. The metal worker hammers the cast loose and kicks the red-hot ingot free. Illicit guns are off the street and out of the heat, smelted into steel ingots that are ready to be worked into beautiful, meaningful jewelry. Liberty United commissions R&D manufacturing in Rhode Island to create jewelry out of busted guns. The cufflink is constructed from 3 pieces: a brass toggle attached to an octagonal brass plate. The brass plate is then finished with a gunmetal moniker. To create the face of the cufflink, the craftsman starts by cutting the steel ingot into planks. A worker drops the plank into an EDM, or electrical discharge machine, to cut it into strips. Inside the EDM, rapid electrical discharges are passed between a wire and the metal being cut. A super hot 1,300 degrees Celsius spark removes tiny pieces of metal that are flushed away with a continuous flow of water. A worker rolls the steel strips to the machining area. He feeds them into a metal press. Rollers squeeze the steel to flatten the gunmetal into 0.6 millimeter thick sheets. At the stamping machine, the metal worker punches discs out of steel sheets. These gunmetal blanks will become the decorative centerpiece of the cufflink called a moniker. At the die stamp machine, the worker presses the Liberty United logo into the disc. Metal discs are set in gold and crafted into distinctive cufflinks. Metalworkers chop and melt confiscated weapons, then cast them into steel ingots. The next step is to create the face that will frame the steel disc. A cutter chops brass strips into small blanks. Then, a hydraulic press squeezes the blank into an octagonal face. A press trims away the edges and punches out the cufflink face. A jewelry maker takes pre-made brass posts and toggles and fuses them to the face with an automatic soldering machine. The cufflinks are ready for the golden touch. The cufflinks are brought to American Plating in Cranston, Rhode Island. The pieces are strung on a rack. The worker dips them into cleaning solvents to remove any grease or contaminants that will inhibit the gold from bonding to the brass. The cufflink parts are then submerged into a bath of electrolyte. Tiny particles of gold in the bath are given a positive charge, while the cufflink parts are given a negative charge. The electrically charged gold particles are attracted to the cufflink parts like a magnet, giving the intricate shapes a perfectly uniform coat. In the final phase of creation, the gold-plated cufflinks are capped with the Gunmetal moniker. A jewelry maker applies a gray stain to the steel to give the disc a weathered patina. She heats them in an oven to bake in the stain. Once they're ready, she removes the metal moniker and syringes epoxy onto the gold-plated face. The worker nests the gunmetal disc and glues it into position. These cufflinks are ready to wear. Illegal guns have been taken off the streets and reformed into high-end jewelry. Profits from the sale of these elegant cufflinks fund programs that help protect at-risk children from gun violence, making them a steal at any price. Conquering the Swiss Alps is a challenge for even the most accomplished skiers, and the slopes take a toll on their equipment too. A downhill skier will discard their beat-up boots every couple of seasons. Now, these high-performance boots will be performing in a very different setting. In Davos, Switzerland, the Argo Foundation employs people with disabilities to process over-the-hill ski boots on a major scale. Ski boots are recomposed into toy flutes. Factory workers have to sort, slice, and shred the boots to turn them into the raw material that will feed a 3D printer. The first step in the destruction process is disassembly. Workers sort through the bins of discarded ski boots. They select just the red ones, the only color that will be transposed into the toy flutes. He places it in an infrared spectrometer to analyze what it's made of. Only one type of plastic can be used. Thermoplastic polyurethane is made up of chains of hard and soft polymers. Its unique molecular structure makes it elastic and tough wearing. The worker marks the boot for processing. A worker clamps the boots onto a vise and yanks out the liners. Using handsaws, pliers, and rotary blades, workers cut and tug the metal clips and buckles off the plastic shell. A worker moves the boots to the table saw to begin the next step in the boot's destruction. The worker cuts away the sole and slices the boots into sections. He tosses the plastic pieces into a hopper. The bits of plastic are swept into the spinning blade of a single-shaft rotary grinder that shears them into pieces. The grinder expels the red plastic shards into a bin. An inspector hand-loads the shards into a belt that passes under a magnet to remove any metal leftovers from the line. The clean plastic bits continue along the conveyor and drop into a bin. A worker feeds the chips into a second shredder, which chews them into plastic flakes. Ski boots have been taken apart and shredded to a fine grind. They're ready to go from boot to flute. Engineers melt the flakes into pellets and extrude them into plastic ink for a 3D printer. Plastic recyclers dismantle discarded ski boots and shred them into red plastic flakes. The shredded ski boots arrive in Rapperswil, Switzerland. The Kremelt facility at the University of Applied Science, Eastern Switzerland, are pioneering 3D printing technology. To print out a flute, the engineers must first create a plastic thread called a filament, which serves as the ink for the 3D printer. The fine-grained plastic is now ready for the first creation step. The engineer scoops the plastic flakes into a hopper that feeds an extruder. Inside the extruder, a rotating screw called an auger pushes the plastic particles through a heated barrel. The plastic melts and becomes malleable. The auger pushes thick strands of molten plastic through a die that creates spaghetti-like strands that are then cut into pellets. Water jets cool and wash the pellets. Once they've dried, they drop down a chute into a bucket. An engineer unloads the coffee bean-sized pellets into a filament extruder. The pellets melt inside the chamber, and an auger forces the pliable plastic through a nozzle. The engineer then grabs the end of the plastic strand as it oozes out of the extruder and pulls it through a cold water bath to harden it. He threads the filament through a series of rollers to maintain a uniform diameter of 2.85 millimeters. An uptake reel winds the new red filament onto a spool. In creation step 2, the plastic filament is ready to be printed into a flute. An engineer threads the end of the filament into the 3D printer's intake port. A computer-controlled arm follows the design program, dispensing plastic ink layer by layer to print out a three-dimensional object. The printer will produce the flute in 4 separate sections: the head joint and mouthpiece, the midsection consisting of 2 barrels that contain the tone holes that alter the pitch of the instrument, and the foot joint. The filament is heated inside the printer, liquefying as it flows through the printer head. Following the programmed instructions, it pipes the molten plastic in thin slices, building up the plastic part a slice at a time. It takes 1 hour to print each section of the flute. The flute parts quickly dry and solidify at room temperature. All that's left to do is to put it together. Thanks to instrumental new technology, ski boots that have gone downhill can be repurposed and replayed as a shiny new flute. All you need now is a little practice. Over 65 million people worldwide use wheelchairs to help them get around. The steel frame chairs are good for about a few years before they wear out and need replacing. Now, discarded wheelchairs are rolling into a different kind of carrier. Ram Iron and Metal Incorporated in Welland, Canada, salvage and process 20,000 tons of metal scrap every day, turning junked wheelchairs into a product that can really deliver under pressure. Wheelchairs are reshaped into beer kegs. Metal workers cut, sort, and melt the wheelchairs down in order to turn them back into reusable steel. The first step in the destruction process is cutting. A scrapyard worker feeds the retired wheelchair into the jaws of an alligator shearer. "2,200 kilograms of pressure chomps the chair into bite-sized bits. The worker adds the pieces to a pile of scrap steel. A crane grabs the scrap and drops it into a truck en route to the smelter. A powerful magnet lifts the scrap steel. Then offloads it into a concrete bin. The steel tracks along the foundry floor and lands into a smelter. The scrap metal melts down at 1,300 degrees Celsius. The liquid flows into a cooling barrel, then siphons into an ingot tray, which forms it into steel bars. Twin lasers sear into the metal, cutting the ingot into small steel planks. The planks feed into a roller press, and they're squeezed into thin steel sheets and rolled into spools. Former wheelchairs have been smashed, smelted, and spun into coils of stainless steel, one step closer to becoming barrels of cool brew. Sheets of stainless steel are cut and crafted into beer kegs. Metal workers dismantle decommissioned wheelchairs and melt them down into spools of stainless steel sheets. The American Keg Company in Pottstown, Pennsylvania is the only company in the U.S. making stainless steel kegs, cranking out 150 beer barrels per day, helping to serve some of the 50 million pints of beer consumed in the United States every year. American Keg Company makes their half barrel from sheets of food-grade stainless steel. It's strong enough to handle the pressure, rust-proof, and easy to keep food-grade clean. A keg is made from 4 sheets of steel. 2 rounded pieces form the body. A piece is rolled into the spear, the tube the beer flows through. And a sheet is cut into 2 short cylinders called chimes that belt the keg at the top and bottom. The first round in making the keg is to cut the chimes. A forklift loads a spool of steel onto a 250-ton press. The machine unwinds the steel sheet and feeds it into the press. The steel strips are embossed with the brewing company's name, material specs, and the date of production so the company can keep track of their kegs. The worker slides the sheet into a bending machine, which curls the chime into shape. He spot welds the 2 ends to hold the cylinder together. Then he places it in a chime-forming machine to fold back the edges and form a rounded rim. A metal punch then knocks a handle shape out of the steel. With the chimes complete, the keg maker begins work on the body of the barrel. The body is made from 2 steel blanks. The worker rolls oil-based boundary lubricant onto the circular blank. This prevents metal stress when the steel is being cast. Then he loads the blank into a 250-ton deep draw press. It stamps the steel into a barrel-shaped form that's used for both halves of the keg body. Time to put the pieces together. A A worker loads the top half of the body into an auto welder and fits the neck blank into a pre-cut neck hole. A robotic torch welds the neck into the spear hole. Then, a welder straps the two body parts into place and tack welds them together to keep the keg intact during the next stage. A worker loads the body into the vertical auto welder. The body rotates on a turntable as the torch welds the seams. The worker loads the body onto a press and positions the chime on top. 7 tons bear down to force fit the chime onto the keg body. A worker loads the barrel onto an automated lathe welder. Clamped between 2 plates, the keg slowly spins while the chimes are welded to the body. Next, an automated gantry crane carrying 12 kegs at a time flies them over the factory floor and eases them into a citric acid bath. The citric acid removes any rust-causing iron particles, finishes the surface, and cleans the keg to food safety standards. A worker inserts a large metal straw called a spear into the top of the keg. When the keg is pressurized, the beer is forced along the straw to the tap. Finally, a worker silk screens the customer's logo on the completed keg. The kegs are stacked and shipped to breweries across the country. Out-of-service wheelchairs have been chopped, scrapped, then tapped to do a brand new job behind the bar. And whether serving up the suds or downing a foamy draft, do it responsibly.